Okay, we're back. This is Techmath1. We're looking at chapter 11. So let's get, there's the marker. Get started, 11.1. Right triangles. So number 1. We have a picture, angle B is an blank angle, and angle C is a blank angle. And the picture here is ABC. With 120 degrees there and 35 here and what is that, a 25 there, 25 there. So angle B, that's this angle, is an acute angle. If it's less than 90 degrees, acute little angle. So less than 90 degrees is acute. C, if it's more than 90 degrees, it's obtuse. Obtuse. All right. In the way olden days, obtuse also meant like slow-witted. If you were, if you saw Shawshank Redemption, there's a part where he tells the warden, "Don't be obtuse," and he's not talking about the angle. He's talking about being, basically saying don't be dumb. Angle T and B are both what kind of angles? Oh, okay, so they gave us another picture. And we got T, B, C, T, B, and C. And so angle T and B both have to be acute because interior angles of any triangle have to add up to 180 degrees. So if we have 90 degrees here, and those two have to add up to 90, well then each one has to be less than 90 degrees. So by definition, if they're both less than 90 degrees, they're both acute. So both B and T are acute. And the sum of T and B would be is 90 degrees. What's missing there? All right, so that's 11.1. That's on page 464 in the blue book. And just some terminology there. Let's look at 11.2. So again, they give us a picture. And so on the picture, we've got number 9 here. They give us the angles of a triangle. So it's 75 degrees and 70 degrees and 35 degrees. And this is little h, and this is little f, and this is little d. They'll do that often. So look, this is not capital, like small letter D, and then the angle is the capital letter. And so that's little h, and the angle across from it is the capital letter, and that's little f. It's got that little, tail on the top, so that capital F is the angle. All right, so I've seen that a lot. That's a math thing in geometry. They do that all the time, where if it's the angle, the opposite side is the little letter. See, the angle H, and then the opposite side is the little letter H. All right, so now that we're talking about opposite sides, so it says angle F is the largest angle. Yes. So that means that side F is going to be the longest side. So if angle F is the largest angle, then the side across from the largest angle, side F, is the longest side. Right? So think about it, think about it, think about it. Here, let me show you. Attach a bunch of markers together. So look. Oh, here, I'll take one less of it. Well, here, we'll make them the same size. So look, if it's a tiny angle, see the tiny angle? See that distance? That's a tiny distance. If I increase it, ooh, now it's a 90-degree angle. Look at the distance increased. If I increase that angle even more to an obtuse angle, see the distance from there to there keeps getting bigger, 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 smaller, 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 smaller. And so the smaller the angle, the smaller the side across from the angle. The larger the angle, the larger the side across from the angle. It makes sense. I mean, if you think about it. So then they're going to say, I think what, side H is the smallest angle H. Angle H is, that's this angle, is the smallest angle. So side H is the smallest side. Or the shortest, probably. Yeah, shortest side. Okay. Let's look at 11.3 again. You've probably seen Pythagoreans Theorem already. But we'll look at number 16 on 11.3, page 468. So we can see the same steps. A squared plus b squared equals c squared. And so, well, they already got that one kind of worked out for us. Here, we'll do it anyway. So the big thing with Pythagorean's theorem is making sure that the side opposite the 90 is always the hypotenuse. That's going to be the one that's by itself. That's always like C. And the a squared plus b squared equals c squared theme C is always the hypotenuse. So that one has to be the side opposite the 90 is always the one that's isolated by itself. And so they gave us, this is 4 and this is 7. And so it doesn't matter which one's A and B. Those are interchangeable because those are legs of the right triangle. It's the hypotenuse, that one you got to get right. You got to get this by itself over there. So if we're taking these values and putting them in there, it's 4 squared plus 7 squared is equal to h squared. And see, A and B don't matter because look, if I say 7 squared plus 4 squared, it's still the same thing. So 16 plus 49 is equal to h squared. So 65 is equal to h squared. And we bust out our calculator, you take the square root of 65. It would be algebraically plus or minus, but since it's a distance, minus doesn't make sense. So we're just going to have just the positive version. And that's, what is that, 8.1 meters. Okay. All right. So then let's look at another example. So this one, number 21, they gave us a leg and the hypotenuse. So they said this is side V, this is side B is 7 centimeters, and side H is 9 centimeters. Okay. So again, we're doing a squared plus b squared equals c squared. The big thing you have to get nailed down is the hypotenuse. This one is the hypotenuse. So that's 9 squared. And then it doesn't matter which one you call A, which one you call B. And so now we got v squared plus 49 equals 81. And now we have to solve that equation. So this time we're going to subtract those two. So minus 49. So v squared is equal to 32. And then we take the square root. Plus or minus square root of 32. But the minus doesn't make sense because it's a distance, so just positive. And then that is 5.7. And that was in centimeters. Okay. So if they give you the two legs, you square them, add them, take the square root. If they give you the a leg and the hypotenuse, square them, subtract them, and take the square root. All right, is the general way that these problems work out. Let's look at 11.4. There's 3 problems we want to do on 11.4. So we got that triangle given. It's number 29 we're looking at. And so they have 30 degrees here. And they just call this one number 2. And they just call this one number 1 for the angles. And it says, since the angles opposite of C, oh, and they have this marked as C and this marked as D. Okay, so it says the triangles with 2 equal sides are called isosceles triangles. Isosceles, remember we got 2 I's in your head. 2 sides are the same on isosceles triangles. Isosceles triangles. All right, that's just the way to remember it. And the angles opposite then are also equal. So the triangle at the right is isosceles with C and D are equal. Oh, well then we can figure out everything. If we know this and this are the same, although my picture doesn't look like it, but I'm just not good at drawing, then we know what number 1 is. Well, because look, if the opposite of D is 30, but this length is the same as this length, then 1 has to also be 30 degrees. Okay? So then we've got 30 degrees and 30 degrees. Number 2 then is, remember, they have to add up to 180 total. If this one's 30 degrees and that one's 30 degrees, together those are 60 degrees. So we got 60 degrees showing and 180 degrees total. So that last one has to be 120 degrees. So angle 2 is 120. All right. Okay. And then let's look at 34. Here they've got, what do they have? I'll try to draw this one a little better. Good. And they're saying this whole thing is 10 centimeters all the way across. And this is D and E and F. Oh, and they're saying that's 10 and this is 10 and this is 10? Okay, so if all the sides are the same, then all the angles are the same. That's called an equilateral triangle. If it's equilateral, it means all sides same. So if all the sides are the same, all the angles are the same. If all the angles are the same and they have to add up to 180, well then you know anytime you have an equilateral triangle, regardless of how big or small it is, the angles are always going to be 60 degrees, 60 degrees, and 60 degrees. All right, so triangle DEF is an equilateral triangle. FG is the height drawn. Okay, so FG bisects DE. How long are those little, oh, there's a little G guy here. Little G. Okay, so DG is then, and DE would be 5. Right? G, Oh, not DE, GE. So DG, this little thing, if this bisects the angle, then it bisects the side. So if that's 5, or if that's 10 rather, then both of those are 5. This length is 5, and this length would be 5. All right. And then let's see, using Pythagorean's theorem, find FG. Oh, okay, so now we're going to take this. That's just this part, so I'm just took that half of it. We know this is 5 from that question. We know this is 10. We know this is a 90-degree angle. And so they want me to find GF. All right? And so Pythagorean's theorem, a squared plus b squared equals c squared. So a squared plus 5 squared equals 10 squared. A squared plus 25 equals 100. Subtract the 25. A squared equals 75. And so A is equal to plus or minus the square root of 75, but only the positive because it's a length. So the square root of 75 is 8.7. 8.7. All right. And then they want the area. Oh, the area. So we haven't done area of a triangle in a while. Area of a triangle is 1/2 base times height. So if we go back here, area is equal to 1/2 the base times the height. Well, they gave us the base is 10. The height we just figured out is 8.7. Wonky looking 10. All right, and then 1/2 times base times height, or 10 times 8.7, and then cut it in half. That's 43.5 centimeters squared. Okay, so that was 11:1 to 11:4.